Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. In today's video session, I am going to discuss about the torque equation of DC motor. So previously we are already discussed about the DC motor. So what is meant by DC motor? What is the conversion of the DC motor, which converts electrical energy into mechanical energy? And what is the principle of the DC motor? When a current carrying conductor placed in a magnetic field, the mechanical force is experienced by the conductor. That is according to Fleming's left hand rule. Right? Now, in today's session, we are going to discuss about the torque equation of DC motor. Okay. So here we need to discuss the torque equation of DC motor here. So torque equation. So what is meant by torque? So torque is nothing but it is force into radius. So torque is nothing but it is a product of force and radius. We can call it as a torque. So here T equal to force into radius, right? For example, I am taking here as a motor. For this motor we are having the radius that is smaller and having the some force that is F. So torque is defined as it is a product of force into radius. We can call it as a torque. So here T equal to F into R, right? So already if the motor is running means some amount of power is developed by the DC motor, right? So that power is I am representing as a power equal to work done with respect to time or energy with respect to time. So work done. So work done means work done in one revolution. Work done for here we are having work done and time is there. So work done for one revolution. So work done for one revolution, that is equal to force into distance. Force into distance traveled by the conductor, that is represented as a force is F and distance already we know that is 2 pi r. Okay, so work done for one revolution is equal to F into 2 pi r. Now time is there. So time required for the one revolution. So here time required for one revolution, that is equal to 60 divided by n is the equation. Okay, here first what is meant by torque? It is the product of force and radius. After that we have discussed about the power. So power is nothing but work done with respect to time. After that, so work done for one revolution is force into distance traveled by the conductor, that is F into 2 pi r, and time is there. So time required for one revolution is equal to 60 divided by n. Now substitute these two equations in this power equation. So then we will get power is represented as a P and work done with represented by W divided by time is T. So P equal to, so work done for one revolution is equal to F into 2 pi r divided by time is 60 divided by n is the time. Then P equal to what? So P equal to, I am writing like this, F into R into 2 pi n divided by 60. So here F into R is nothing but torque, 2 pi n by 60 is nothing but angular frequency, that is omega. Okay. So here, so power P equal to F into R is nothing but what? into, so I am writing here 2 pi n divided by 60. Now power is there, so power of DC motor or power of DC generator, here both the power equations are same here, that is P equal to power P equal to Eg into Ia. So power developed by the DC motor or the mechanical power developed by the DC motor is P equal to Eg into Ia, right? Now substitute this P value in this equation. So we'll get Eg into Ia, that is equal to T into 2 pi n divided by 60 is the equation, right? Now Eg, so since already we know Eg is nothing but 5 Znp by 60A. So generated EMF of DC motor or DC generator. So here both the for this both the generated EMF is same only. So Eg equal to 5 Znp divided by 60A. Now substitute this Eg value in this equation. So we'll get 5 Znp by 60A into Ia equal to armature torque, or so torque into 2 pi n divided by 60. Here 60 get cancelled and n get cancelled. Now by using this equation we have to find out the torque. So T equal to 1 by 2 pi into 5 Ia into Zp divided by A is the torque equation of DC motor. Okay, so the torque equation of DC motor is T equal to 1 by 2 pi into 5 Ia into Zp divided by A, or we can also write T equal to 0.159 into 5 Ia into Zp divided by A. Here is another equation of the torque, T equal to 0.159 5 Ia Zp by A, where phi is flux, Ia is the armature current, Z is total number of the conductors, P is total number of poles, and A is number of parallel paths. Okay, here is the torque equation of DC motor, right? So now we'll discuss about some problems on the torque equation of DC motor. So here I am taking the problem here. A 4-pole DC motor takes an armature current of 6 ampere. The armature has 480 lap connected conductors, and the flux per pole is 20 milliweber. Now we need to calculate the gross torque or armature torque developed by the motor. Okay. So here first we have to write the given data first, after that we have to calculate the torque. So here a 4-pole, so total number of poles P equal to 4. A 4-pole DC motor takes an armature current, that is Ia. Armature current is represented by Ia equal to 6 amperes. The armature has 480 conductors. The armature has total 480 conductors. So total number of the conductors are represented by Z, and in this DC motor we are having the total 480 conductors, and it is a lap connected. If it is a lap connected, the condition is A equal to P, that is equal to P equal to what? 4. right? So lap connected, that is A equal to P, that is equal to 4. And flux per pole. So flux produced by the each and every pole is 20 milliweber, or 20 into 10 to the power of minus 3 Weber, right? Now we need to calculate the torque. So what is the torque equation? T equal to 0.159 into 5Ia into Zp divided by A. So substitute these all the equations here. So we'll get 0.159 into what is flux? 20 into 10 to the power of minus 3 into armature current 6 into total number of the conductors 480, total number of poles 4, and A parallel paths 4. Now by calculating this, here, we'll get 9.158 Newton meter is the torque of the given DC motor. Okay, here is the one problem on the torque equation of DC motor. So I will take one more problem. So here a 4-pole DC motor takes an armature current of 50 amperes. The armature has 480 lap connected conductors and the flux per pole is 20 milliweber. Then calculate the gross torque developed by the motor. So now here also first we have to write the given data first. So a 4-pole DC motor, so total number of poles P equal to 4 poles are there. So total number of poles are 4. DC motor takes an armature current. So previously armature current is 6 ampere, now the armature current is 50 amperes. The armature has 480 conductors. So total number of the conductors Z is equal to 480 and it is a lap connected conductor. So if it is a lap connected, A equal to P, that is equal to 4. Suppose if it is a wave connected, A equal to 2. Okay, so here it is a lap connected, so A equal to P, that is equal to 4. And the flux per pole phi equal to 20 milliweber, that is equal to 20 into 10 to the power of minus 3 Weber, right? Here is the flux. Now we need to calculate the torque. So torque equal to 0.159 into 5Ia into Zp by A, that equal to 0.159 into 5 value 20 into 10 to the power of minus 3 into armature current 50 into number of conductor is 480, number of poles are 4 and A parallel paths are 4. Now by calculating this we'll get 76.32 Newton meter is the torque equation. Here is the torque of the given DC motor, that is 76.32 Newton meter, right? Here is the some problems on DC motor and the torque equation of the DC motor, right? So in next session we are going to discuss about the different types of DC motors. Okay, so thank you one and all.